All right, so let's solve this one. We have equation 1 and we have equation 2. What do we do? By inspection? By inspection. Now, wait a second. I want to see something. Give me a second. So by inspection, we notice that the y terms are not in the same position for both equations. Like, for instance, the first term in equation 1 is a y term, but the first term in equation 2 is an x term. So it means that we have to switch them around, right? Which one do we switch around? The x's or the y's? For the first, which one are you going to switch? The second equation or the first equation? Which one do you think would be easier to deal with? I mean, it probably won't make no difference, really big of a difference, but what would you do?
The first.
Right, first, because when you switch around the 2x and the 3y, there's no negative signs, right? So it's easy to just work with that. So we can just do that right here, over here. So we can see 2x what? Plus, very good, 3y equals 13. Now some people will say, if you switch them around, shouldn't you change the sign? And what would you tell them? No, don't change the signs, very good. Why not? Why not change the sign? When they think, okay, if I switch them around, that's like transposing. Is that true? Is it like transposing when I switch them around?
No.
No, why it's not like transposing? How is transposing different?
Transposing when you go over the equal sign.
Very good. Very good. Transposing when you go over the equal sign. All right? Really learning. Okay, good. So, because we actually have the two terms on the same side, moving them around on the same side will not have that kind of effect. And if you want to think of it like, okay, you're leaving Antigua to go to the States, right? You know, you're a dual citizen. You know, when you're in Antigua, you're Antiguan. You go to the States, you're American. But if you're in Antigua, if you move from one place in Antigua to the next place in Antigua, still Antiguan, right? Very good. So it's when you're switching around terms on the same side, it's just like that. You're still in the same country. So we're gonna have the x minus y equals 4. That's our second equation. So it's still equation 1, even though we switched around the terms. Equation 2. So you did good. Now what we're gonna do here? What are we gonna do here? By inspection, here we have the x's aligned now, the y aligned, and the constants after the equal sign, those are aligned as well. What do we do next? Can we go ahead to just add and subtract just like that? Or would we need to multiply? So what are we going to multiply? Which equation are we going to multiply? Equation 1 or equation 2?
1.
You multiply equation 1 by a number?
Equation 2 by 2.
Equation 2 by 2? Okay. Multiply equation 2 by 2. So what would that give us? We have 2x plus 3y equals 13. Yeah, go ahead, talk to me. What would we get here?
2x minus 2y equals 8.
Very good. So multiplying x by 2 give us 2x, multiplying y by 2 give us 2y, multiplying 4 by 2 give us 8. So okay, so now we have these two equations. What are we going to do? Do we add or subtract them? Subtract. Very good. Because they're same quantities, right? In 2x. When you subtract, you get 0. Now we have to think carefully about what we do next. Okay, 2x. Let's want to write the long way. I just want to subtract them from here. Subtract them from here. Okay, let's do that. 2x minus 2x will give us what?
0.
0. So cancel out, right? Next, what we do next?
2.
So what would happen here? Think about the signs. So when you have the long way, can I see what's happening? Let's write it. Let's write at least 3 plus
2y. Negative 2y.
Okay. Not sure about that. Let's write it the long way. We don't have to write the x's, the y's. We'll go over that again. We don't have to write the x's because we already cancel them out. But we can write the y's, right? So let's write. Tell me what to write. Let's write out everything that we're seeing there. Tell me what to write.
Positive 3y.
Positive 3y. Because it's the first term, we don't have to write it now. 3y, minus
2y. Negative 2y.
Negative 2y.
Equals 13 minus 8.
Okay, so how do we fix this now?
3y plus 2y.
3y plus 2y. You see, so it's actually easier when you see it like this, right? Unless you decide, okay, from now on, I'm going to just do this. You could do that as well. Combine it into one sign. And what would this give you? Subtracting negative. So you're saying it like this. Subtracting negative will give you a positive. So it's going to be what? 3y plus 2y. Right?
Mm-hmm.
What's 13 minus 8? So go from 8 to 13. 18, how much you have to add on to get 13? That's the difference. 5. So go from 8 to 10 is 2. From 10 to 13 is 3. So 2 plus 3 is 5. Okay, what do we do here from here now? Simplify. What is 3y plus 2y? 5y. 3 plus 2 is 5. 5y. Okay, 5 times the number give us 5. What's that number?
1.
That means y is 1. Alright, you can divide both sides by what?
5.
Good. Next step, what's the next step? We're going to substitute
Y equals 1.
Y equal 1
in equation.
Which equation you want to use? Equation 1? Okay, sure. Let's write equation 1. Remember equation 1?
2x plus 3y.
2x plus... Okay, 2x plus 3y equals 13. 2x plus 3y equals 13. So it's going to be what? 2x plus 3 times 1 equals 13. True?
Mm-hmm.
So 2x plus 3 equals 13. What do we do to both sides? Take away what? Take away 3. Very good. So from both sides, we're going to subtract 3. Why not add 3 to both sides? Why take away 3? Because we want to get 0. We want to make this 3 0. Right? We want to subtract this 3. We want to remove it from both sides. So we only have 2x on that side. So these will cancel out to be 0, right? So we're going to left with what? 2x equals 10. Alright, 2 times the number is 10. What number is that? 5. So that means x is 5. So we can divide both sides by 2. So x equals 5. So we have that what? Y is equal to 1. X equals 5 as our solution set. Or as an order pair, I always have your x term first. The value of x first. 5, 1. It's understood. So the first number you're seeing in the bracket is the x value. It's always like that. Never put the y value first as an ordered pair. Okay, so let's look at the next question. Alright, so we're looking at these two equations now. This is what, the third one? What are we going to do? Looking at equation 1 and equation 2, we have to inspect both of them. Do we just go right ahead and subtract, or are there certain things we need to do first?
You have to change them.
Change what?
Put the x's by the x's and the y's by the y.
Right, so we need to align them, right? Okay, good. So which one would you think makes more sense to align? The second equation, change around the x and y terms for the second equation, or for the first equation?
The first equation.
Okay, if we switch them around for the first equation, what would we have at the beginning?
2x.
Would it be just 2x? What sign the 2x has? Negative. I know you've seen minus, but we can't just switch it around like that because the order of subtraction matters. So we're going to treat it, the 2x as a negative 2x. Right? So we think of it as 3y plus negative 2x. So if you put the 2x first, you have to put the negative sign in front of it. So it's negative 2x plus 3y. So wouldn't it be easy to just move the y and the x terms in
Equation 2.
Right, because they're positive. So, but you could do that with this, just that you'd have a negative 2x plus 3y equal 11, which nothing is wrong with that. then x plus y equals 12. In fact, you know what? Let's do it like that. Let's work with it this way. This is still equation 2. Change it. This is still equation 1. Just switch it around. All right? Because you could have equation written like that. How are we gonna deal with it? All right. So tell me what to do now. What do we do? Hmm? Just like that? Look at it again. Look what you have.
Multiply.
Yeah, you can. If you add just like that, you're not going to be able to cancel off any of the terms. You won't be able to eliminate either the x terms or the y terms. Whether add or subtract. So we're going to multiply. Which one of them you want to multiply? Talk to me. Which one do you multiply?
Equation 2.
By what?
2.
By 2? Okay. So we're going to put back equation 1. Negative 2. Let's write back. Yes, let's write equation. The new equation 3 coming from equation 2 first. 2 times x is going to be positive 2x, right? It's be positive 2x. 2 times y is 2y, and 2 times 12 is 24. That's equation 3. What's the next step after that? Write back equation 1, right? So we'll leave that unchanged. Okay, so now what do we do after that? Think through this. Do you add both equations or do you subtract both equations? But do not answer just like that. Think through it to determine whether you're going to get 0. Would you be able to eliminate either the x terms or the y terms? Should you add or should you subtract? Think about it and tell me. You just guessed, or you think about it and you see that you will actually eliminate. Okay, because you're uncertain and you're not responding means that you just gave me an answer. Try to subtract and tell me what would you get. Think about the sign after the subtraction. What would that turn out to be? What would you be subtracting? What would you be subtracting? Tell me. Let's put subtraction. What would you be subtracting?
2x from 2x.
No, look at it again. Read it. Read
2x
it.
from negative 2x.
No. Read it. Let me hear. Read it from top to bottom.
2x minus negative 2.
Right. The one that is written last is the one that's coming from the one that's written first. The one that's written first is considered to be what you have, and what you're taking from it is what you have after. So now let me ask you: if you subtract negative 2x, if you write it out the long way, you see why writing out the long way might be the best thing for you for now? Okay. Or what are the ways I told you can actually do it? You can circle the signs. Okay. Circle the signs. What sign would that become? A plus. So what answer would you get if this becomes a plus? 4x. Do you want 4x? What do you want?
0.
0. Yes, you want to eliminate it. So therefore, should it be a minus or a plus? A plus. Okay, so now we use a plus. Let's highlight it then. Adding a negative will give us what?
A negative.
A negative. Okay, so we have a negative there, right? So read it. So read it now without the 2 signs, but the new sign. 2x.
Plus.
No, we actually brought this to 1 sign. We brought these 2 signs here to 1 sign. So read it with the new sign.
2x minus negative 2.
No, we
Minus 2x.
right. We brought these 2 signs in a circle. Right, so you can't read them. You can't mention any of them again. They're no longer there. Okay? They're combined to become the minus you see now. So it's 2x minus what?
2x.
Good. So does adding work? Okay. So what we're gonna do here? Add. You see, so that's the biggest issue that you're gonna have. So you need to make sure you study that little part there. Go over it one more time when when you get a chance. Just go over it again in your head as to why it works, or how you next time when you get a quiz or a test that you're gonna ensure that you don't put the wrong operation. So you have to test it out. So if you have a minus like 2x and you have negative 2x, if you put minus, this will become what? Plus, and end up with getting 4x. Did not eliminate. Even if you decide to put 0 there, or you cross it out because you're saying, okay, it should be 0. No, you have to ensure you put the right operation, addition. When you add negative, it becomes a minus. So you have 2x plus negative 2x, right? You end up with what? 0. Okay, so let's go. So this will give us 0, and 2y plus 3y is what? 5y. 24 plus 11, that's 35. And then we want to do what? Divide both sides by what? 5. Or we can say 5 times what gives us 35, and that's 7. So y is equal to 7. Since 35 divided by 5 is also 7. All right. Okay. So now we found the value of y, so we're going to substitute y equals 7 in one of the equations. Which equation you want to use? Okay, you always use equation 1. Okay. All right, so let's get equation 1 up. So let's go to just look at which one looks easier and which one looks easier. One equation 1 or 2?
2.
Let's use equation 2 this time. So x plus y equals what? 12. All right, in equation 2. So let's change from equation 1 to equation 2. All right, so what we're going to have next? What to do next? We're going to write equation 2 as I did here. I'm going to substitute. What I'm going to replace? Which one I'm going to put? X or the y?
Y.
So x plus 7 gives me 12. What x must be? What plus 7 gives us 12? Count from 7 to 12. 7, don't count that, but 7, what comes after? 8, that's 1. 9, 2, 10, 3, 11, 4, 12, 5. So x is what? 5. Alright? Or you can say x plus 7. What we're going to do, subtract what from both, how much from both sides? We're going to subtract from both sides. 7. So this cancels off to give us the x equals 5. Or the other technique, x plus 7 equals 12. Transpose, the plus 7 goes over the equal sign, and you mentioned that once it goes over the equal sign, right? Should the sign of the 12 change? Why not?
Because it was already there.
It's already there on that side, right? Yeah. Very good. So that's going to give us what? 5. So that's another way you can do it. Transposing. Rather than, taking the number from both sides. Alright, so we know that x is equal to 5 and y is equal to what? 7. Remember, we can always test your answers, check your answers, right? Let's check our answers. X equals 7, x equals 5, y equals 7. Let's check. All right, so because we use because we use the last equation, equation 2, to get our final answer, let's do the testing in the equation 1. We substituted in equation 2, so let's use equation 1 to test. So we know this will actually work because that's what we substituted in. So let's use equation 1 to test. 3y is just checking. It's not part of the solution. 3y minus 2x equals 11. We said that y is equal to what amount?
7.
So that's 3 times 7 minus 2 times 5, right? Will we get 11? Let's see. 3 7s, 21. 10. And 10 from 21 is 11. You can clearly see that we got that. So remember, when you're testing, do not check. When you're checking, do not check in the equation that you just substituted in. Check in the other one to verify. You can check in both in the, but you want to save time by just checking in one of them, and the best one to start checking is the one that you did not substitute in. Okay, so let me just go back up so you can write this down. Equation 1, equation 2. All right, by inspection, what do we do? Do we need to switch around any of the terms to align?
No.
No, because x is already aligned, the y's are aligned, constants. So what do we do next?
No. Multiply.
Okay, so we multiply what? Talk to me. Which one of them should you multiply?
Equation 2 by 2.
Right. Question. What if you decided, I don't want to get rid of the y's. I want to get rid of the x's. What would you have done?
Equation 1 by 3 and equation 2 by 5.
Equation 1 by 3. All right, that's what you just said a while ago. Equation 1 by 3. Equation 2 by 5. Very good.
What do you want?
Oh, the other way around, yes.
Mhm.
Equation 1, equation,
1 by 3, equation 2.
right. Thank you for the correction. Okay, so do you want to do that? We're going to end up with some big numbers, though. Yeah, let's do that. All right, so what we're gonna end up with now? 3 5s will give us what?
15.
So 15x plus 3 2s 6y and 3 2s 60, right? 3 times 20 is 60.
Yeah.
Okay, and equation 2, 15x. Because there's sometimes when you don't, you have to do that based on the numbers they give you. All right. It's just that the LCM of 1 and 2 is 2. That's why you would have multiplied equation 2 by 2 and it would have worked. We'd get rid of the y's. But when you whenever the lowest common multiple is a number outside of those two numbers, you have to multiply both equation by that. Like the 5 and 3. The multiple is the lowest common multiple is what? 15, right? So you have to go outside. Equation 5 by 3, equation 3 by 5, equation 2 by 5. Okay, so 5 3 is 15, 5 times y is what? What goes here?
5 by
And 5 times 14,
7.
70. Alright, so let's do this now. What would add or subtract? Subtract. What is 6y minus 5y?
Y.
Y. What's 60 minus 70? Think about it. 60. You're taken from 60, 70.
So you need to
Yeah. Negative what?
1.
Negative 1. To move from 60 to 70. To move from 60 to 70, how much is that? 10. Yeah. Negative 10. Okay, good. Next. What do you want to substitute? You want to substitute y equals negative 10 in which equation? Doesn't matter. Which one you want to just give me 2. Left equation 2. 3y plus y. 3x. 3x plus y equals 14. Equation 2. And let's substitute inside of it. So we have 3x plus the y is what? What's y? Negative 10. What's it going to give us? 3x. What's plus negative? Give us what? Adding negative will give us what? Negative. Got it? And but when you have this, adding negative, negative. So even if you have a bracket like this, let's separate them. If you have this plus outside and a negative inside, it's still going to end with negative. Remember to say like you're multiplying them, right? Okay. Next. Let's simplify this further. How do we get rid of the 10? The subtraction of 10. How do we get rid of it?
Transpose.
Transpose. So 3x equals 14. When you transpose it, what it becomes? Plus 10. So 3x equals 24. Alright, and then we're going to divide both sides by what? By 3. 3 and 3 goes once, right? 8 times. And so this gives us x equal what? 8. So two solutions. Y equals -10 and x equals 8. As a solution in terms of order pair, which one do I put first? X or y? X, which is 8, -10. Right, if you want to write it like that. Let's check our solution. Which one did we substitute in? Equation 1 or 2? 2. So we're going to check our answer with equation 1. Alright. Let's go back to equation 1. 5x plus 2y. Let's do a substitution. We're trying to get 20, right? Will it be equal to 20? This question. What's x? 10 or -10?
-10. No, that's y.
Y is -10. And 8 and
X is 8.
And x is 8. Okay, good. End up with what? 40. 2 tens, 20. Plus minus what was it? Minus 20. We got 20, right? So it worked. Alright, so that's that there. So let's make sure you want to write it down now. That's the last one.